So who's ready for another round of LZW encoding? Well, here it is, coming right up. So in the last video, we saw what LZW encoding is and what it's used for. Here's a brief recap. LZW is a lossless compression method. It builds up a dictionary and assigns a code to a sequences of characters. If you need to, you can always go back and watch the first video on LZW just to be sure. Okay, so let's start by going right back to our algorithm. We were trying to compress the word ABCDBCA using LZW. This is as far as we got, to the first C. So let's go ahead and pick up with the D. The next character after D is another B. The output is once again the code for D in the ASCII table, which in this case is 100. Now we put the current character and the next character together and see if this combination is already in the dictionary or not. Since DB isn't in the ASCII table yet, we make a new dictionary entry using the next index value that isn't taken. So we assign DB index value 259. Okay, now our current character is B, and the next character is C. And now, uh-oh guys, watch out. You see, up until now, every sequence of letters we've come across hasn't had an entry in the dictionary yet. But we do have one in there for BC already, index value 257. Now, if we happen to have an entry in the dictionary already, we just don't put anything under output. We don't give it a dictionary entry either, since we already have one. On the next line, the current character isn't a single character, but the character sequence that's already in the dictionary. So in this case, BC. The next character is going to be A. Since BCA isn't in the dictionary yet, for output we put in our current character. So that's BC index value 257. For the dictionary entry, we put in the current character together with the next one. This gives us a character sequence of BCA with an index value of 260. And now we're down to the final character, A. There aren't any more characters after this one. For output, we enter the code for A again. Since there's no characters after this one, there's nothing to put in the dictionary either. And that's it. We're done. Now to get the complete coded sequence, we just write out the contents of the output column from top to bottom. If we write the letter corresponding to each code, we get our text. And that means we've successfully compressed it using the LZW method. Now let's see what happens if we convert the characters to bits. When we do this, our text comes out to 49 bits. But if we convert the LZW codes, the text is only 42 bits. So we save 7 bits. Now in reality, the data quantities that we usually deal with are a lot larger, which means that you saved a lot more space. In any event, now you know exactly how LZW works. LZW encoding works the same way with images. You've got an image with various pixels, so you go through each pixel line by line, entering the pixel sequences into the dictionary. This allows you to assign a single code to several pixels at once. Since computers don't actually see colors anyway, but give each color a specific code, this works really well. Well, that's it for LZW for now, but don't worry, we're still going to look at how to decompress our LZW encoded data. What do you need to remember today? LZW is a lossless compression method. It builds up a dictionary and assigns a code to sequences of characters. If a particular sequence isn't in the dictionary yet, just put the current character under output and make a new entry in the dictionary. But if the sequence is already in the dictionary, just skip the output and the dictionary entry and go down to the next line. Alright people, it's been real. If you're still down for more videos, just click on the next one. See you!